Hello everyone, my name is Ludovic. I would like to present you my first Capstone project for the M2M Tech program. So the goal of this project is to use Python to evaluate the running performance over time of data pulled from Strava. And Strava is a platform that keeps track of many kinds of activities, as you can see here. And for each activity you can see some metrics over the course of the activity, such as the heart rate or the cadence. So the first step is to export the data from Strava. So you have a link here and it will send an email containing a download link to a zip archive. And inside that archive, what will be interesting for us is the activities 1, where for each activity there is a fit file. The issue is that it's a binary file, so we will rely on an open source package called fitpass. And it lets you read the data clearly, and for that it will be useful to convert it to a CSV file format instead. So we will focus only on specific data. So for each record we will take the time, the daytime, the cadence, so this is the number of steps per minute, the speed, meter per second, the heart rate, beats per minute. So yes, so all that Python program that I wrote gives you as an output all the CSV files inside the same folder, like that, and we will just select and concatenate all the running relevant CSV files inside two types of CSV, two types of activities, so treadmill and run. And from now on we will jump to Google Colab instead. So I uploaded the two CSV files there. As we can see, we have the timestamp, the heart rate, the cadence and such. So we will read both CSV files and put them in a data frame. And we will be using only one merge data frame. For the rest, we are adding some informations. So for example, instead of speed, what's more relevant is the pace. So here's the conversion. We will remove some records, some data which are not relevant here, because for example low cadence means that we're just walking and we want to see the running performance instead. And we're adding some aggregated information for the visualization just next. So the first visualization is a scatter plot, and we have here the heart rate per pace. So it means that, for example, here at lower pace, at least at this pace, we were around 150 heart rate beats per minute. And the faster we're running, the higher the heart rate is, which is logical for sure. But we can also see that for lower paces we have higher heart rates as well, And this line tell us why. This is because we're just running uphill, so with higher elevation, so that's why there are more effort and thus more an increase in heart rate as well. For the size of the plots, it's the number of data points that we have for each. So that means that my sort of sweet spot where I'm running the most all year long is mostly between 530 and 630 minutes per kilometer. And lastly, the colors. So from blue to red, it's 2016 to 2025 of this year, and that tells us that in the past I was just running more efficiently, or at least more effortlessly, with less effort than the recent years. And we can have some 3D representation which gives us some indication. For example, we can see for 2019 that my heart rate barely were sort of contained between 145 and 160 in heart rate, whereas in the more recent years, for example, it can go all the way up to 175. So yeah, probably not the best indicator of performance. Anyway, the duration. So this chart tells us that with the higher number of activities, so we can see a lower average heart rate. Sorry. And once we were in the COVID period, the average heart rate just started to increase because I wasn't running as often as before. So yeah, pretty much it. For the cadence versus pace, what that means is that with higher cadence, meaning the more steps per minute, I was running just quicker, basically. So this is something that I'm trying to reproduce since the latest years, since I realized that. Yeah. And that's pretty much it. The last one is just everything that I already said before. So that's it. If you have any comment or question, feel free to reach out. Thank you.